Hey folks, welcome to this channel and welcome to this video. I'm Saptarshi Mukherjee. I'm a software engineer 3 at Google and a computer programmer. So in this video, I'm going to discuss this 2D DP problem, the sixth problem from the CSES problem set of DP problems. Um, it's an interesting problem, and this actually is a stepping stone to many such problems. It says that there is an n cross n grid whose squares may have traps. It is not allowed to move to a square with a trap. So you can't move to a square which has a trap. Now you have to calculate the number of paths from the upper left square to the lower right square, and you can only move right or down. So the movements are given that from a certain cell in which directions you can go. The cells where you cannot go, those are also given. So this kind of an input will be given. You will have the n, that is the number of rows and number of columns, and then you will have that many rows and that many columns, each dot telling that it is vacant, each star telling that it has a trap. We have to print the number of paths modulo 10 to the power 9 plus 7. So let's look at it. This is the same graph, I believe. Yeah, more or less the same graph. So basically, if you have to reach over here using only down and right, like from here you can start the options to the right, right, down, and then you get stuck. You can't go from here. You can't go to the right or down anywhere. You cannot go to the trap. This is not allowed. So this is not going to be like, if you start in this way, you cannot go anywhere. You cannot complete a path. So you have to go back, go back. Okay. Now, what is a path? This is a valid path. Similarly, you can have other valid paths like come down, go there, come down, right. Okay. You can have some other things as well, like using the gray. If I try, probably coming down, or using the yellow color, coming down, going to the right, and coming down, going to the right. I get three ways. Let's see how many ways are there. Looks like those are the three ways. So yeah, these are the three ways. Now we have to say in total how many ways are there. This is a classic DP kind of a problem. Here you are accepting n square elements, so n square is lesser than the time limit. N is only 1000, so n square is totally fine. So you can use this kind of a structure as the DP state. Try in a simple way. You basically want to know in how many ways we can reach from certain place to a certain place. Last few problems also we discussed of the same thing. From somewhere to somewhere, how can we reach? So in this case, we are going from the source, that is 0, 0, to the destination. This is the source, and the destination is n minus 1 comma n minus 1. Last row, last column. This is the destination, this one. Now the thing is, in how many ways it can go. So we can view this problem in the same way, that hey, it's the same like the number of coins, or the yeah, minimum number of coins, or the coin combinations needed to get us some the problems that we solved before this. So we know that okay, if this is an intermediate point, this is another intermediate point, another intermediate point, I can reach here, let's say, in, like, these are three ways in which I can reach. Let's say from S I can reach these three things directly, and from here there are X ways to go, from here there are Y ways to go, from here there are Z ways to go. I can say the answer becomes X plus Y plus Z. So this is from the source perspective, that from here if I say that there is one way to reach this destination, and from here if there are two ways, I can say 1 plus 2 equals to 3, the answer for the source. That is evaluating it towards the source. Another is going gradually away from the source towards the destination, where we say for source we know from the, I mean, so basically we will calculate everything with respect to the source. That, let's put something like this. Okay, this is the source. Now in all the adjacent places we have one way to go. We have one way to go, in each of the adjacent blocks. If there is some block from where we can go from two of these places, then the number of ways to reach there becomes 1 plus 1, that is 2. Similarly, there can be a place where we can go from all the three, and then it becomes 3. And then if there is a block where I can go from this one as well, this one as well as this one, then the total number of ways becomes 2 plus 3 equals to 5, something like that. Which means I'm gradually taking this from the source. So I'm defining my dp. If I do the second way, I'm defining my dp in this way, that dpi is equal to, or dpij, let's say, for every cell I will define it. dpij is equal to number of ways to travel from 0 0, that is the source, to ij. We will do this for every ij. We will start with the smaller ij's, and then gradually when we move over here, we already know that whatever is the number of ways to reach here, the same answer will be here. So we will start solving with the smaller ij's and then gradually move towards bigger ij's. That is the strategy. So let's see. At 0 0, we basically have 1. Why? Because to reach the source from the source, there are no such ways. There is only one way, you can say. There is one way to reach from the source to the source, that is stay over there. So this is your base case, dp 0 0 is equal to 1. This is a basic case, and dp n minus 1 n minus 1 is supposed to be your answer. This is the answer. You need to find this. So in how many ways can you reach this? You can come to a cell from the left and from the top. This is a very common solving strategy, a strategy that is used very commonly for solving 2D DP problems, where you go through that DP state from the portion where you're comfortable to the portion where you don't know the answer. So start from the top left and then keep on going. And then how can you go? Row wise or column wise? Totally up to you. Sometimes row wise, sometimes column wise. In this case, both approaches will work. So let's go row wise. So basically, this cell, you can come to it from the left or from the top. From the top you cannot come. You can check that using the row number. From the top you cannot come, so only from the left. Whatever is there, you can copy that. So it's 1. Similarly for the next, it's 1. It's 1. So basically, dpij is equal to dpi minus 1j, that is the top number of ways to reach the cell to the top, and dp ij minus 1, that is the number of cells to reach the left cell. So it means that if this is ij, if this is ij minus 1, the top one is I minus 1j. If you can reach here in x ways, if you can reach here in y ways, that means you can reach here in x plus y ways. This is the meaning. Now you should check whether this is valid or not. So if I is greater than 0 and if j is greater than 0, then you should take this term or take that term. Otherwise you should treat as that term as 0 if j is 0 in that case. Let's solve it over here. Our I is 0, so we will take we will ignore this term. We will take this case, dp ij minus 1, that is the left cell. So whatever is in the left, that gets copied. Now we are coming to the next row. Here the first cell will follow this formula, dpi minus 1j, that is the top thing gets copied. It is one way to reach here. Now go towards the right. This is a trap. You cannot go. You cannot go there, so basically there are 0 ways. You can write a 0. Wherever there is a trap, dp of ij is the number of ways to reach there, that is 0. You cannot reach there. Now here, what is the answer? The left value plus the top value. From the left you cannot come due to the trap, from the top you can come in one way. So 0 plus 1 equals to 1. Now here, in how many ways can you come? You can come from the left, that is something like this. This one tells you can come from the left, this one tells you can come from the top. So 1 plus 1 equals to 2. You can come in 2 ways. From here you cannot reach the answer, that is a different thing. but you can come here in two ways. If you carry on the process, then it's 1 from the top, then 1 plus 0, that is 1, then 1 plus 1, 1 plus 1, that is 2, and then over here it will be 1 from the top only, and then over here it will be 1 plus 2 equal to 3. There are three ways to reach over here. Here it will be 3 plus, the next one would be 0, so 3 plus 0, 3 plus 0 would be 3. So this 3 becomes your answer. So again, this is the main recurrence relation which we are following, with some exceptions like this. dp00 equals to 1, dp n minus 1 n minus 1 becomes our answer. Same paradigm, we are reaching from the source to the destination. If we know all the states, if we know we have to go step by step in the form of this kind of a 2D table, make that 2D table, go step by step. You can go row wise, you can go column wise, first the first column, then the second column, and so on. In this case, both would work, both are totally fine. In some cases, you should, according to the question, take the call whether you should go row wise or you should go column wise. And sometimes your constraints will be so high that you need to optimize this. For this problem, you cannot do, because you have to read the cells, find out the traps anyway, and square time will get taken. For some other kind of problems, maybe you have to put an extra thought, okay, can there be some formula of finding out the last answer? Sometimes there are. So in that case, you need to reduce your space and time complexity by somehow computing what answer will come at the last position. But if you have the space and time complexity available to use this kind of a state, you can just go left to right, top to bottom, and solve your problem. So this is a very common kind of a DP. Let's take a quick look at my code. Here's where the code starts. I'm going from 0 to n. I'm taking both I and j. So this ij represent my cell. This I and j together represents my cell. Then I'll say if a star is contained, then there are 0 ways to reach there. If I equal to 0, j equal to 0, then there is only one way to reach there. I've written it as a condition that if both I and j are 0, there is only one way to reach. And you could have written a separate loop for the first row, but it's totally up to you. And here is the ternary operation for this last thing, that okay, if I is greater than 0, then take that term I minus 1j, otherwise take 0. And if j is greater than 0, then take that term ij minus 1, otherwise 0. And then do the modulus operation. Finally, print ways n minus 1, n minus 1. That is the last element. So I hope you find this useful, and if you take part in contests, you will see that this pattern of questions will be frequent. Yes, you might have to do some other steps. Yes, you might have to be a bit careful to take care of some extra things, but this is a classical problem which is a stepping stone to many such problems, to a wide variety of competitive programming problems. Hope you enjoyed the video. Hope you'll enjoy solving the problem. So see you in my next videos. Take care. Bye.